All right, in the last two videos, we learned about the servo and the ultrasonic distance sensor, and we got parts of their code to make these work integrated in our robot's code. What we're going to do is, in this video, put those into our program together so the robot can make some decisions about where to go. What I've done here is just used a little hot glue to attach my servo to the distance sensor, and used one of those plastic pieces that comes with the servo to attach to the part that actually rotates. I didn't have a good place to glue this directly to the front of my car, so I just used some scrap wood here, but that creates a place that I can attach the servo on the front there, and now it's got kind of a little head that can be rotated to the left and to the right. I like to not screw the servo into that white piece before gluing it down, so that if this does run into a wall, it'll pop it off instead of breaking something. And it does make sure that if I accidentally install this not at its center position, that it can still get the full range of rotation correctly. For example, that was incorrectly installed there. If I want it looking all the way to the left, I can make sure that I move that around, and now I've got that full 180-degree range of rotation. All right, so let's switch over to the code and see what we need to add to make this thing function. So here's our get distance function that we wrote last time. To have our robot think intelligently about its environment, we're going to add a little routine to our loop section here. So let me go ahead. I'll leave our test routine in there and take out some of the stuff we had from the last video. So what's our code going to look like? Well, it starts to get a little bit more complicated at this point. So doing some planning with something like a flowchart or some pseudocoding is always a good idea. So we can take a look. I've got my loop function and flows down this direction until we get to the end of the loop. And then like the loop does, it will continue. I'm going to have the robot first measure the distance straight in front of it and then ask a question. Is there more or less than half a meter of travel room? If the distance is not less than 50, that means there is room. So just move forward a little bit, stop, and then go back to the top. So we'll kind of see the robot scooting forward as long as there's room in front of it to do that scooting. But if it somehow measures straight in front of it and finds out there's less than 50 centimeters, it's going to do a different operation. Then it's going to turn its head to the left and the right, measure the distance, and ask another question. Which direction has more room? And whichever one is correct, it'll turn that way. So to the left or the right. Then once again, it'll measure the distance in front, make sure it's clear. And if it is, it'll continue moving forward again. And if it's not, it'll try turning in a different direction again. So the diamonds in our flowchart here are going to have us using a new coding structure that we haven't used yet, which is a if statement. The if statement is where robots can actually decide something based on a little test that we give it. So first of all, let's do like the main loop part here, this measure the distance in front of the robot. So I want to make sure my robot is looking forward. So I'm going to use our command from a few videos back that controls the servo. There's my servo.right, and I'm going to have it go to 90 degrees, kind of in the middle of its rotation there. It does take some time for that servo to move. It's not instantaneous. So I'm going to add a little delay in here, maybe about 1/5 of a second, just to make sure it's actually looking forward before we do the next thing. In order to get the distance from the sensor, we can use our new get distance function. But we need some place to hold whatever the value is that this returns to us, so we can actually look at it. I think that an appropriate variable name would be something like distance front or dist front. And I just created this, right? So I can't use it down here if I haven't, declared it. Let's go to the top of our code and add it as a variable that we can use globally. So here's all my stuff related to the distance sensor. I'll kind of include it in this list. So we could just make a new line and say dist front like we've done so far. But as long as we're not setting it equal to some starting value, we can do this. We can just have a comma there. It's still an integer type. We can add it here where we had the distance centimeter. As long as we're up here, you can imagine later in the code, we're going to need to measure left and right. So I'll need variables to hold those distances as well. Let's just add dist left and dist right while we're there. Okay, so cool. Now we've got this global variable, and we can set that variable equal to whatever this number is that comes back when we use the distance sensor. Next, we ask the question about that distance. Is that distance less than 50 centimeters? So here's our first use of an if statement. We're going to say if the dist front is less than 50 centimeters, do what is in between these curly brackets. All right? So if it is less than 50, do this stuff. All right, the rest of our code. So let's pause on looking at that for a second and see what happens if the answer is no. So if distance is not less than 50, we said we wanted it to scoot the robot forward a little bit. So we'll use our go forward function. Going forward a little bit might be something like 200 milliseconds of going forward. And then I want to make sure the robot stops again. So we'll call full stop. And let's be generous here. I'll have it stop for a full half of a second there before it does its next check in front of it. We can really see if this is working the way we want it to. If things go well, we could, have it stop for a shorter amount of time or even remove this entirely. I just want to make sure it doesn't run into a wall at full speed. So it's good to bring it down there. All right, now back up to our if statement. What do we find if the distance is less than 50? What are we going to do there? Let's take this stuff and kind of write some comments into our if statement so we know what we need to do. Looks like we need to measure the distance to the left and we need to measure the distance to the right. So that's going to include also moving the servo. And then we're going to ask, is right greater than or equal to left? If it is, turn to the right. If it's not, turn to the left. All right, so see if I can remember all that. We want to turn servo to right, then we want to measure that distance. Then we want to turn the servo the other way and measure that distance. And then we ask a question. We say if the right distance is greater than left, turn to the right. And the other situation is if the left distance is greater. We'll turn to the left. Cool. What we did say in our flowchart here was to measure the distance in front again before moving. The way I have it right now is that it will actually move forward a little bit before it gets to the measure at the front there. And that's because I just want to focus on using if statements. We could use if else or even just else statements to make it exactly match the flowchart, but this will be a good starting point, just introducing if by itself. All right, so here's our plan. Let's turn this into actual code. So turn servo to right. We're going to use the myServo.right function. And if 90 degrees was in the center, remember we could go to 0 or 180. So turning to the right, I'm not sure if that's 180 or 0. I'm just going to guess. I'm going to put in 180. When we upload this to the robot, if it actually looks to the left first, I know I need to come in and debug this and switch it around. Okay, so that's the only input that takes. Turn servo to the right, measure the distance to the right. So just like we did with measuring the distance to the front, I can actually just copy and paste this. We're going to call the get distance function, but we're going to set it equal to one of our other global variables, distance right. Next parts of the code here for looking to the left are going to be pretty similar. Oh, there's one thing I need to add here. Remember, it took a little time for the servo to actually move to that position. So I'm going to add a delay here again, just to make sure it has some time to actually go and look that whole direction. Okay, so turning to the right and measuring the distance to the right. Turning to the left and measuring distance to the left. Pretty much identical. It's just going to go to the other extreme. I want to make sure it's got some time to get there. And once it's actually looking left, we're going to measure the distance, but assign that value to the left distance variable. All right. Now we get to the question, and you probably guessed it. It's going to be an if statement. This is where it's going to compare these two numbers that we just gathered, the right distance and the left distance. So if what? That goes in our parentheses here. If the distance to the right is greater than left, so using our mathematical inequality sign there, do what is between these curly brackets. And what does it need to do? It needs to turn to the right. How are we going to turn it to the right? Well, a couple videos back, I think three videos, we looked at that new function that we included called point turn right. And the point turn right function had the car do a multi-point turn, ending up kind of pivoting it to the right without having to travel too far. And this did take an input. It was how many times to do the back and forth motion. So I'll put 5 in there, but that would, depend on your robot and its turning radius and how long you actually have it moving backwards and forwards for. For the other situation here, let's write this whole thing out. If the left distance is greater than the right, so if dist left is greater than dist right, do what is between these curly brackets, which is turn to the left. And again, I'll use the point turn left function. We had point turn right, point turn left, and I'll do an equal amount. Cool. So with these if statements, right, if any of these are false, it'll skip over it and check the next one. And if that's false, it won't do anything at all. There is the possibility here that distance to the right could equal distance to the left. And if that's the case, it'll just try to go forward again and then probably run into a wall and end up being less than 50 and then take a second stab at trying to measure what the distance is. But this should be a good starting point to see if this works. And if you remove all of the comments here, that wasn't too long, maybe about 20 lines of code there. And remember, we're in the loop area, so this should be able to repeat over and over and over again, continuing to try to turn and move in the direction with the most open space. Let's compile this real quick, see if there's any typos. Done compiling, so that checked out. Let's upload it to our robot and let it run around a little bit and see how it looks. I'll get some footage of that and add it to the end here.